Simon with TGS, and so TGS is a leading provider of seismic and well data to the oil and gas industry. And there's lots of ways that seismic data can be used to reduce risks when it comes to drilling wells and placing wells. And what we're doing when we are acquiring seismic data is we're using sound waves, sound energy, to build maps of the subsurface by listening to the amount of time it takes for the signals to return. And with these images we can identify structures in the earth that will enable us to locate where there's oil and gas deposits. One way that we are using the latest imaging technology to build these pictures more accurately is through the use of algorithms such as reverse time migration, which allows us to build very accurate representations of the subsurface. We can incorporate information about the character of the rocks and the quality of the rocks by bringing in what we're calling anisotropy, which is a feature of the rock. When we incorporate that into our imaging processes, we get much more accurate placement of the images horizontally and laterally. When a well is being drilled and the path of the well is being planned out, that additional accuracy in the imaging that we can provide enables companies to much more accurately place the final destination of their well, and hopefully be more successful in achieving a successful result from that well. One of the ways we can use existing seismic data to improve the placement of wells and to provide information when deciding where to put wells is through the use of shallow hazard surveys. What we're doing with the shallow hazard survey is using data that we've already acquired to provide a high-resolution image of the subsurface. In the subsurface there can be a number of things such as shallow gas pockets or shallow water flows that can cause problems when drilling a well. And by carefully processing the data that we've already acquired, we can provide a volume that enables our clients to identify these risks and then avoid them when they're planning a well, pick sites where those risks are absent. This has two advantages. One, it means that the wells are likely to be more successful, and secondly, it means that we don't have to go and acquire another survey in order to get that data that we need for the shallow hazard identification. We can use data that we already have, so we're reducing the number of surveys that we need to acquire. When we're acquiring a seismic data set, what we're doing is inputting sound energy into the earth, and then we're recording the amount of time it takes for it to return to the surface. So what we need to understand is how the seismic energy, how the sound energy moves through the subsurface. And when we have that understanding, we can take that sound energy that we record and turn it into accurate pictures of the subsurface. And one of the latest techniques we're using is reverse time migration. And with our clients, we're using that algorithm to build extremely accurate pictures of the subsurface, so we can identify the structures where the oil and gas deposits will reside with a high degree of accuracy. As the sound wave moves through the earth, it changes its speed depending on the direction of its motion, and that's known as anisotropy. And if we incorporate anisotropy into our images as well, we get much better placement of steeply dipping events such as the flank of a salt dome or a steeply dipping reflector. And that's very important for us because when we're drilling, when a well is being drilled or when a well path is being planned, we need to know with a high degree of accuracy where these steeply dipping salt flanks and steeply dipping sediments lie. And so being able to model that is extremely helpful for our clients when they are doing that planning stage.